The example that I'd like for us to work with is trying to solve the differential equation y double prime minus xy equal to 0. This is an initial value problem, so it's going to be okay if we have unknown constants at the end. And we're already in the form y double prime plus py prime plus qy equal to 0 for p equals 0 and q equal x. Minus x. And we can see that x0 equals 0, which we'd like to be what we called an ordinary point, is fine because 0 and 0 and minus x don't break anywhere, so 0 is a perfectly fine value to have. And in fact, because q and p don't break anywhere, the radius of convergence is going to be absolute value x less than infinity. So it will be the entire real line. Now that we know a solution exists and has a nice domain of x where it will be true, we're going to go ahead and take our y that we want to plug in. And the derivative that we're going to plug in. So we're not going to need that middle derivative y prime. I'm just jumping right to y double prime, which is the sum from n equal 2 to infinity of n times n minus 1 c sub n times x to the power n minus 2. Then for the ODE, we have 0 equal to y double prime minus xy is going to be equal to the sum from 2 to infinity of that derivative series minus x times the series for y. And then from here, we're eventually going to want to combine our series, but first I need to put this x inside the series it's multiplying so I don't have to deal with it later. And remember, I multiply just like polynomials, so x to n times x is just x to n plus 1. And that's going to happen in every single term in my series. Multiplying by x increased my power. And now that I have two series, I'd like to combine them. So I need to make sure that they match in powers x. And I'm going to take them both to power x to n. That should be enough room for me. Sometimes my sums are just very bad. So both these series I want to go ahead and move so that they have power x to n. This one's less steps, so I'm going to do it first. So originally I had n plus 1, which took me to power x0 plus 1. If I start with xn, that means I need to start from n equal 1 to start out that same x to 1. Now I can reason through this started at c0, so then my cn is going to have to be minus 1, so that when I plug it in, I get 0 again. Or I can reason through, I subtracted 1 to get here from n, so I need to do it to every n I see, I subtract 1 there. Whatever reasoning makes most sense to you, go ahead and do it. Now this one, I took a couple extra steps, so my change in numbers is going to be a little different. Here, when I plug in 2, I start from 2 minus 2 is 0. So if I start at xn, that means my first n must be 0. Then to match, I can think I added 2 to get from n minus 2 to n, so I'm going to add 2 to everything in here. Or I started at 2 times 1 times c2. So this must be 0 plus 2 times 0 plus 1 times c0 plus 2. And I'm going to rewrite all that so that it doesn't look so weird. And I could check, n minus 2 became n, that's plus 2, n became n plus 2, that's plus 2, n minus 1 plus 2 is n plus 1. Or I could check by term. When I plug in 0, I get 0 plus 2, 0 plus 1, c2. Okay. So now that my two series have the same power x, I can go ahead and meet the second condition that they have the same lower bound. I tend to like moving all of mine up to the same thing, so I'm going to move all of mine up to n equal 1. So I want this first series to start at 1, but it starts at 0, so I need to go ahead and correct for that. By plugging in my 0th term, that would also have an x to 0 on it, and adding it out front. So I could recombine these into one series that starts at 0, but I want to hold on to only the series that starts from 1. At this point, I am ready to simplify and combine my series, but I do need to move to the next slide to do that. So pause if you need it. We're really close to the end here. So that first part that I pulled out front just simplifies to 2c2, and we will talk about what to do with that when we get to the next step. But for now, I just want to make sure that my entire series is inside one series. That series has lower bound n equal 1 and goes up to power x to n. And then I'm just combining the coefficients I had, n plus 2, n plus 1, c n plus 2, and then subtracting what I had on that second series, minus c n minus 1. And at this point, I've reached the end of step 6, manipulate into a single series with the same power xn. In our next video, I'm going to go ahead and do steps 7 and 8, but we're actually going to need some more guidelines for how this actually turns into coefficients that we can evaluate.